红色的日落沉没在海平底线，夜色慢慢摊开，露出星光点点。我听着。
In order for us to know more about tectonic hazards, we need to look at the structure of the Earth first. So here we have the core. Core is the hottest layer out of the Earth, and the heat comes from the radioactive decay of elements. The core is made up of iron and nickel, mostly. Well, for core, we have two sections. The first one is the inner core. For inner core, it is a solid, while for the outer core, it is molten. Why is it solid? Because of the high pressure. After talking about the hottest layer, now we are moving on to the thickest layer, which is the mantle. Mantle actually has the space which allows the crust to move. So for mantle, again, we have the lower mantle, which is closer to the earth, and this again is solid, while for outer mantle, we have a mixture of solid and liquid and molten. So for molten rocks, they are called magma. So for the temperature of the core, it is around 3,000 to 5,000, while for the temperature of the mantle, it is around 1,400 to 3,000. Last but not least, it comes to the crust. Crust is sort of the ground that we are stepping on right now, and crust is divided into two sections. One is oceanic crust, one is continental crust. The continental crust and oceanic crust have different properties. One differing properties is that for oceanic crust is denser, while continental crust is less dense. Hence, we have aluminium as an example of material for continental crust, while for oceanic crust, it can be made up of magnesium. And another property is that continental crust is actually less thick, around 5 to 8 km only, while for continental crust is thicker, 35 to 70 km thick. So this is the internal structure of the Earth, and when the crusts are broken up into smaller pieces, they are called crustal plate. For tectonic hazards to take place, it must involve some movement of the plate, and we are curious to learn about why do plates move in the first place, and that relates to a science concept which is convection current. So we have this typical diagram being drawn to us in physics, so it is able to be connected into geography as well. However, there are some changes to the diagram. So we imagine here is crust. So the first step, as the magma in the mantle is heated up at the core, it expands and rises. So when it reaches here, it spreads out under the crust, and this causes the crust above it to move away from each other. Okay, so there are also times when it actually moves downward. So when the magma is cooled and sink, this actually causes the crust above it to move closer to each other, and this is reversing the crust spread away from each other. When the continental crust and oceanic crust, they interact with each other, the denser oceanic crust experience this of slap pull force, and this causes it to subduct beneath the less dense continental crust, and this drives the downward portion of the convection current. So this will keep recurring, setting up a convection current for the crust to move continuously. And last but not least, how do they exactly have different types of hazards? And this have to do with our three types of plate movements. We have divergent movement, we have convergent movement, we have divergent movement, we also have transform movement. Let's start off with the easiest one, which is the transform movement boundary. Okay, so the two plates, they slide past each other and they experience shear force. So there will be cracks, and in the process of faulting, which can have earthquake in place. And next, we are referring to the divergent plate boundary. So we have continental, and oceanic. So for the case of oceanic divergence, what will happen is this. It will firstly, faulting will happen. So there will be cracks on the Earth's surface. So the faulting will then cause an earthquake to happen. So as the plates move away from each other, there is a process called seafloor spreading, and this will cause the formation of oceanic ridge. Okay, the magma will rise and solidify, and this is the oceanic ridge. Example is the mid-Atlantic ridge. And last but not least, when we are referring to this diagram, there is also volcanicity, where the magma actually rises through the cracks and fissures of the crust and form volcano. Similarly, for convergent and convergent CC divergence, we are also experiencing faulting when there are fault lines incurred, and this will cause earthquakes to happen. After that, we'll also be seeing things like land subsidence. What do I mean? So imagine that there is crust here as well. So when this crust moves away from the rest of them, and this crust moves here as well, this piece of land will sink. And this is called rift valley. The remaining one is called the block mountains. Okay, again, volcanicity will happen and volcanoes will be formed. Last but not least, we talk about the convergent CC, OO, and CO convergence. So when two oceanic plates converges against one another, they will experience compressional faults. So again, there will be fault lines, so faulting will happen, which lead to earthquake. And when we talk about the oceanic crust, whenever there is oceanic and moving towards each other, there is again the slack pull force, causing the process of subduction to occur. And whenever there is subduction, there is a deep linear depression, it's called oceanic trench, being formed. And at the same time, magma will rise through the cracks and fissures, volcanicity process resulting in the formation of volcanoes. That is for OO convergence. We also have this CC convergence. Okay, so when the CC plates converge with one another, they move towards each other, they will actually push each other. Okay, the correct term is that the crust actually buckle and fold, and the landform resulted in is the fold mountain. Again, fault lines will be produced and there will be earthquakes as a result. Volcanicity will happen as well. For CO, it's basically a combination of both of them. So we are able to see landforms such as volcano, fold mountain, oceanic trench, and all of them the product of OO and CC. Here we come to the end of the plate tech KQ1.